I'm Natasha Speer. I'm a faculty member in the Department of Mathematics and Statistics and a member of the Humane Rise Center. And as part of this larger NOYCE project, I've been working along with my colleague Eric Pendicio to develop some curriculum materials for the two courses that we provide our pre-service teachers focused on mathematics education. And part of what we've been doing is to ensure that pre-service teachers have opportunities to familiarize themselves with some of the things connected to the Common Core state standards that might not have been in the curriculum that they went through when they were students. And our focus in that is to help teachers be prepared with the mathematics content and also to know about how students will be thinking and learning the ideas, and also to help them become more familiar with how assessment is done around particular ideas in the Common Core. Our focus is specifically on transformational geometry, and you may be familiar with how geometry is taught in high school, where we look at a variety of shapes, often triangles, and we develop ideas of proof in this two-column format where we say we're given these ideas and what are the reasons that we can claim these things. And we use this as a structure for helping students understand both the nature of proof and also some ideas about what makes two triangles the same, congruent, or other sorts of features of triangles. However, in the Common Core state standards, there's been a shift away from this two-column proof structure and towards a different approach for developing congruence and ideas around triangles. And the reason for this shift is that two-column proof structure is not at all how mathematics is really done. And it's a very rigid structure that allows support for students learning ideas, but it doesn't share very many features with authentic proof. So instead of doing it in those ways, what the transformational geometry focus in the Common Core does is say, if we have a shape here like a triangle, and we want to know whether it's the same or congruent with this other shape, what are the transformations of the plane? What sorts of things can we do to rotate or flip or do other things to that shape and see whether they land exactly on top of one another? And although some of those ideas are familiar to students from lower grades, like translations and rotations and reflections, they may not be familiar with how to use those tools to then create proofs. So what we also were trying to do in these instructional materials was to do something that would be appropriate for use in what in the math community is called a capstone class for pre-service teachers. And in those capstone courses, what we do is we take an idea from a lower level grade and we trace how that idea appears in the curriculum as you go up and all the way up through upper division math major courses. And so in our project, we started with Common Core sample items around transformational geometry, and we then looked at how those ideas of transformational geometry and congruence and a variety of other things then appeared in lower division undergraduate courses, so like in a calculus class or something like that, and then also how they appeared later in a mathematics major's career in an upper division class around groups and number theory.